Have you ever shuffled across the carpet in your socks and then gotten zapped touching a doorknob? That tiny jolt might seem harmless, maybe even funny, but it's actually a glimpse into a much bigger problem, one that can wreak havoc on the technology we use every day. That's ESD, electrostatic discharge, a sudden flow of electricity between objects with different voltage levels. It's the invisible culprit behind many mysterious malfunctions, and it happens more often than you might think. It's a natural phenomenon, but for sensitive electronics, it can be a death sentence. Even a tiny zap, far too small for us to feel, can destroy delicate microchips or corrupt data in an instant. That's where the EN 61004-2 standard comes in. EN 61004-2. It's an international guideline designed to protect electronics from these sneaky, destructive surges. Imagine you just finished building a cool new gadget, maybe a weather station that sends data to your phone. You've spent hours soldering, programming, and testing every feature. You're stoked to test it outside, but then disaster. Suddenly it stops working or starts acting up in ways you can't explain. It acts weird after a few days, giving you crazy readings. Maybe the display flickers, or the data just doesn't make sense anymore. Unbeknownst to you, ESD from the wind rubbing against its plastic case is messing with its circuits. Static can build up from the environment, not just from people, and zap your device when you least expect it. That's why we need to take ESD seriously, folks. It's not just a lab problem, it's everywhere. And it can strike at any time. In 61004-2 is a set of rules that help manufacturers make sure their gadgets can survive those little jolts of electricity. It's about building resilience right into the hardware. It's like a boot camp for electronics, pushing them to their limits to ensure they can handle the real world. Devices are zapped, shocked, and stressed to see if they'll keep working reliably. And believe me, these tests aren't messing around. The goal is to expose weaknesses before the product ever reaches your hands. This standard is all about making electronics tougher and more reliable. It's the difference between a gadget that fails in a storm and one that keeps on ticking. Think about it. You don't want your phone to fry just because you touched it with static charged fingers, right? Or your laptop to crash after a simple shock. In 61004-2 helps prevent that. It's the silent guardian making sure your devices survive the shocks of daily life. In the next section, we'll dive deeper into what this standard actually tests and how it works, so you can see just how much goes into keeping your electronics safe. So how do we make sure our gadgets can handle ESD? In a world where electronics are everywhere, from your phone to your car's dashboard, protecting them from electrostatic discharge is more important than ever. Even a tiny zap can cause glitches, malfunctions, or even permanent damage. That's why engineers and manufacturers need a reliable way to test and toughen up their devices before they ever reach your hands. That's where EN 61004-2 swoops in like a superhero. This international standard is the go-to guide for ESD testing, setting the rules for how we challenge our electronics to make sure they're up to the task. The standard outlines specific tests that simulate real-world ESD events. It's not just about zapping devices randomly. There's a science to it, with carefully defined procedures and equipment. We blast electronics with carefully controlled zaps to see if they can survive. These tests mimic the kinds of shocks a device might face in your home, office, or even out in the field. Two major players in this testing arena are contact discharge and air discharge. Each method targets different real-life scenarios, making sure no weak spot goes unchecked. Contact discharge is like touching a doorknob. Direct contact, a sudden jolt. It's the most straightforward way to deliver a shock, and it's used to test surfaces that people might touch. We use a special gun that delivers a precise electrical wallop to our device. This helps us see if the device can keep working, even after a direct hit. Air discharge is a bit sneakier, like that zap you get from a sweater. Electricity jumping through the air. This simulates those moments when a spark leaps from your finger to a device without actually touching it. For this, we use a different gun that generates a spark, simulating a more distant ESD event. It's a crucial test for parts of a device that aren't usually touched, but could still get zapped. The test levels are no joke either. We're talking thousands of volts, way more than what you get from shuffling on a carpet. These high voltages push devices to their limits, revealing any hidden vulnerabilities. We crank up the voltage and zap the device at different points to see how it handles the stress. Every button, port, and seam gets tested, ensuring no part is left unchallenged. It's like a mini lightning storm for our electronics. But hey, better to find out any weaknesses in the lab than in your living room. This way, we catch problems before they can cause real-world headaches. These tests are rigorous, but they're essential for making sure our electronics are tough enough to handle everyday life. Without them, devices could fail at the worst possible moment. After all, we use our devices everywhere, in dry climates, humid environments, even around things that generate static, like carpets and certain fabrics. The standard ensures devices are ready for all these challenges. EN 61004-2 ensures that our gadgets can take the heat, or rather the zap. Thanks to this standard, you can trust your electronics to keep working, no matter what static surprises life throws your way. ESD, or electrostatic discharge, might seem like a harmless little shock, just a quick zap you feel when you touch a doorknob or your favorite gadget. But under the surface, it's a whole different story, especially for your sensitive electronics. Imagine the tiny electrical components inside your devices, the brains and nerves of your gadgets, intricately connected like a bustling miniature city, each part working together in perfect harmony. Now picture a sudden surge of electricity, sometimes thousands of volts strong, coursing through those delicate pathways. It's absolute chaos for those tiny parts. These high voltage surges can cause serious, often irreversible damage to your electronics. They can melt microscopic wires, fry ultra-sensitive transistors, or even punch right through insulation, creating dangerous short circuits that are hard to detect. It's like a lightning strike hitting an anthill, sudden, powerful, and incredibly destructive for something so small. The damage might be invisible to the naked eye, but it can cause all sorts of problems, from random glitches and erratic behavior to total device failure. The worst part? ESD damage can be cumulative, building up over time with each little zap. It might not kill your device instantly, but every shock weakens it, like slowly chipping away at a wall until it finally crumbles. Over time, these micro shocks can lead to frustrating performance issues, mysterious crashes, or even data corruption that's hard to recover from. In the end, ESD can leave your favorite gadgets completely dead, all from something you might never even see or feel.